Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to work on a Commodore 64. It's this motherboard that was sent in by viewer Brett, and Brett found that this computer had this really elusive fault that they were not able to fix. And in the end, they ended up socketing every single chip on the board except for, it looks like, well, 2 chips, and the problem was never found. So in this video, I'd like to try to diagnose this motherboard, see if I can figure out exactly, well, where the fault lies, and get this thing working to give Brett the solution to the problem that was so elusive. So without further ado, let's get to fixing the Commodore 64. Now, viewers might be asking, why am I not working on the Lisa again? Because I keep talking about the fact that I'm going to get back to the Lisa. Well, as you can see, this table is still here with all the turbo mail call items on it. And I need to clear this stuff and organize before I can kind of get back to the Lisa, because I need that space for the Lisa. Space is tight down here in the basement. So that's why I decided to divert and work on this 64 again, because I knew this wasn't going to be a simple fix, and well, I don't think it will be, at least. And I think maybe it'll be kind of interesting to try to solve this elusive problem. Now just take a look at this motherboard. Whenever you have so many sockets installed, if you are not really good and careful with the socket installation, you can easily rip a trace or damage a pad, where when you reinstall those sockets, you might not have a good connection, and then that can actually exacerbate the particular problems that the machine already had. Now, it goes without saying, we're missing a lot of the larger ICs on this machine. All the ROMs are gone, the CPU, the SID, and the PLA, along with the VIC-2. But actually, Brett sent those along, so I have a couple boxes here, because I think Brett ended up trying a lot of different chips. So in this first box, we have a VIC-2, we have a SID chip, we have some of the ROMs. I think there's no PLA chip, if I am correct. Some regular TTL logic, and then we have a second box that has more TTL logic, or actually no, this has a whole bunch of DRAM and some additional logic, along with a couple brand new of these connectors. This is for the joystick ports. I don't know why one has been removed. Maybe it was damaged on this board, and Brett was trying to get this fixed, but we have a replacement for those, which is great, because these are not super easy to find. And Brett sent in this letter. I kind of skimmed over this in the Turbo Mail Call episode, but let's take a look at this in more depth just to see if there's maybe some kind of a clue as to what the problem is here. Brett says, when I acquired this board, the CIAs had been unceremoniously removed from the board along with one of the LS257 chips, I think U13, wrecking some traces. This required some bodge wires to try to restore the damaged traces, where I installed sockets and replaced the missing chips with known good ones before I could do a test. So we can see up here there are some bodge wires installed around the CIAs, and one of the 257s, I don't really see, oh yeah, there's a bodge wire there as well. We'll take a look at that more in a second. With sockets installed and all the missing chips replaced, when the machine was fired up with the dead test, the screen came up like this. We can see the colors are wrong. Some of the text is kind of working, but then there's supposed to be a table down here showing you the RAM chips and stuff. That's kind of messed up. A little bit of the color information is getting through, because I think the lines of the table are supposed to be red, but the background's not supposed to be black, and the letters aren't supposed to be this blue color. The font is working. This is definitely the dead test font that's loading. So that's something. I started to check over the board. My first targets were to replace the other LS257s, U25 and LS139 at U15, because they were the MOS branded equivalents that are known to be unreliable. No change. I did a bunch of research on what could be causing this. I ended up replacing the LS08, LS258, and LS373, chasing down similar symptoms, probably from what other people report, but no change. Eventually, my troubleshooting led me to one of your videos, I think from 2021. I tried to find it, but I was unable to do so, which had a very similar looking screen as above, except the colors were correct for the dead test screen. Your video led me down the path of trying to see if one of the RAM chips might have failed, since that was the fix in the video, and it seemed like it might have been a bit too RAM chip. You will find my notes on this in one of the little boxes with chips in it. Okay, there's a little note, it's like a handwritten note. However, what fixed the problem in your video had no effect on this board, so I ended up socketing all of the RAM and replacing them with known good ones. No change. I then socketed and swapped out the CPU, no change. I swapped the VIC, the PLA, the color RAM, and one of the 4066 logic chips that seem to be on the same data line as bit 2. No change. Finally, I removed the character, basic, and kernel ROMs to see if one of those chips could be impacting the data line 2 by holding it high. No change. In case you're wondering, you could take those ROM chips out and run the dead test ROM, no problem. It does work fine without them. This is where I finally gave up and threw in the towel, having put in several hours trying to fix it with absolutely no progress. Pretty much every chip on the board west of the RF modulator and VIC chip has either been socketed, replaced, and or removed entirely, and I could not find the fault. It's very possible that my bodge work was badly done, and I've inadvertently kept data line 2 high somehow, which is causing the garbled text. I hope you might be able to find the fault and correct it. If not, I'm sure you can make good use of this as a donor board. In the extra little boxes, we have all the original memory and logic chips that were on the board when I got it, except for the MOS branded logic. Also in the box are a few sockets for extra ROMs and character ROM, 2 extra basic ROMs, and 3 Rev2 kernel ROMs. There's a Chinesium SID chip, marginal but functional to a degree. Yeah, I noticed this chip when I was doing the mail call episode. That is clearly rebadged, and what's hilarious, let me get a little closer so you can see it, 6581 R4AR. This is one of the desirable SIDs. So it seems what they do is they rebadge every kind of SID. I mean, it's probably a 6581 with the 4AR, since these are the ones that people seem to like. But you could tell this is a rebadge. So this is the way MOS mark their chips, like these, not with a laser like this. So clearly fake. Also a telltale sign is you see these little dimples or divots. They're barely visible. That's because they sanded this chip down and remarked it. So if you go to buy a SID from AliExpress or eBay, it's most likely going to be one of these, and it's going to be expensive, and you're going to get a marginal part that may not even work, because I doubt they even have ways to test these, although maybe they have a 64 they can actually put them in now. Who knows? But are they really testing them for quality and binning them properly? I doubt it. Brett goes on to say, in that same box, there is the R56A VIC2 chip. That's the worst VIC2 chip, in my opinion. These are the ceramic ones that are very early. There are versions that look like this that are actually R8s, and those are good. But for NTSC land, R56A, they don't look that good. They don't have as many luma levels as the later ones, and the video output quality is just poor. In the other small box, I've sent 2 joystick ports, had to steal a port from the board I sent you for another repair, a couple new old stock color RAMs, that's 204s, a bunch of NE 556s, mostly new old stock, a bunch of 4164 RAM chips, some 7406s, 4066s, several other logic chips, and that might help in some of your future repairs. Thank you for all you do, and keep the great content going. Sincerely, Brett. Okay, Brett, thank you very much for the nice letter. If we take a look at the little note, U22, and it looks like Brett was doing some calculations on what characters were displayed and what they ended up turning into, just to try to figure out which bit was stuck. And I think the determination was it was always bit 2 that ended up always being high. And I've demonstrated that a bunch of times before in previous videos. You look at what you're getting with the dead test cartridge and or whatever, if your 8-bit computer's turning on, you're getting something that looks like a message that you can read, but the characters are wrong. You can try to figure out then what exactly is getting stuck that's causing those messages to have the wrong letters. All right, so back to this machine. Let's start just looking very carefully to see if there's any faults. It sounds like Brett does a lot of repairs on these things, so I'm relatively confident that Brett did a good job socketing all of these ICs, because we can see here that this stuff was all removed very well. Obviously, whoever removed these original CIAs, or these, not these two, but the ones that were in this board originally, did so with extreme force, which ended up damaging the board. And it could well be that we just still have damage left over from that. So that's what we really need to focus on. But of course, the first thing we're going to have to do is just sort of look around, see if there's anything that's sort of obvious. And then we're going to need to populate a CPU and a PLA chip so we can kind of get this machine booting again, because I want to see with my own eyes what the dead test looks like. It's not likely the problem lies over in this whole section, so we don't really have to worry too much about it. I wonder if this stuff was socketed by Brett or was already socketed. It's not normally socketed around the VIC2 chip. That's just clock generation stuff. Obviously, because this was getting a normal picture, we can say that the voltage regulation is working properly. And then down here, we have a whole bunch more socketed stuff. But like I said, we could just pretty much assume that this is all probably socketed properly. This RAM, you know, I'm going to say that RAM looks a little suspect, but there was a ton of RAM in the box. And suspect is like, these look like they've been remarked also. And, oh, maybe not. See how like there's little divots and there's a number written in there? I don't know. It's just these markings, they look too new for 1986. It's like laser etched. They weren't laser etching things in 1986. These have got to be rebadged. They have to be. Brett included a whole bunch of RAM, so we can pretty much assume that this RAM, whatever's happened to it, still probably works fine. All right, so on the back side of the board, let's take a look at the bodges. So it definitely looks pretty rough, but obviously this bodge is fixing that trace, which is clearly damaged. Although I don't know if it's even necessary, you know, if you're not using the user port. This 6526 is handling the user port, among other things. Or does that look like a broken trace right there? Whatever that is, it's bad. So I don't know where that goes. I can just grab another motherboard and we can compare. Of course, the other motherboard I grabbed still has its RF shield on it. Great. Okay, so I took the ZIF64 motherboard out of the case since this one is the same revision as the one that Brett sent in. I just noticed something that is completely unbelievable to me. I think everyone has seen this board a million times. I mean, I've taken it to VCF shows, I've done so much with it, but occasionally I've been having a weird issue where this particular CIA doesn't work quite right and the keyboard can have weird random characters. Well, I just flipped this over and I think that might be the reason why it doesn't work all the time. The socket is not even soldered in. I mean, it's been like that since I made this, and that's years ago. I can't believe it. The number of hours I put on this computer, on this exact motherboard, in this condition. There's so many hours, and it's not even soldered down. What? I just can't freaking believe it. Now, one thing that probably helps is that these pins are wider than normal pins that are on typical sockets. So you kind of have to jam it into the vias. So I guess it's kind of making contact, but clearly not all the way. All right, well, I need to fix that, obviously, and then that'll make this thing work again. But at least we can see all these other traces perfectly to compare to the one here that has been damaged. All right, so this bodge wire that goes from that point to that point, that is actually what this trace is here. I thought maybe it went to one of these pins, like it would go there to there, but it doesn't. Because if we just compare to this board, that's the bodge wire. It goes from there to there. So that's been fixed by Brett. So no problem there. Although we don't know with 100% certainty that, for instance, this trace that goes down this way, I mean, I didn't check, but we need to check to make sure that it goes from here down to this point. So I'm going to be using this multimeter here. This is going to be our friend for this exercise, just to verify and be sure that all of this stuff is connected properly. Okay, so that's the first bodge wire there. It's fine. And it goes down to there, which it does. Okay, good. And then I think without question, this is properly connected to there. Yes, it is. And then we should just double check. None of this stuff is shorted together. Seems fine. Same over here. This is a bit melted, this bodge wire, but it seems like it's okay. It's not touching any of this other stuff that is nearby. Of course, it does touch there. That's because this is the trace that, oops, a little flip thing flipped off. That's the trace that it's connected to. Let's just make sure it's not touching there or here. Good. Okay. Seems okay. Part of the problem is, though, is when you have severe damage, I don't have the microscope handy, but you kind of have to really double check. Well, we don't even know what's happening on the top side either, but you do have to really try to double check that, for instance, like this looks pretty bad. I don't know. We're just double checking things here, right? Okay, so that is connected and it's not connected to there, which is good. Seems that everything that's like really close to the pins are what kind of got damaged here. Okay, so that trace is good. That's this trace that runs right alongside those pins. Okay, well, let's just check here on the other chip just to double check. Okay, this trace here that's sort of exposed runs right along. That one is fine. And let's check the other one that runs along here to there. That looks fine as well. And I'm just going to make sure it's not shorted to any of these pins. Yeah, it seems okay. Okay, our other area of damage. Wow. was right here. So ripped pads. Oh boy. All right, so just checking the work. Seems fine, just checking for shorts as well, because this stuff is so close, right? So we have to make sure like this is not shorted to there. See how it's very, very close? Without a microscope and better lighting. There's a lot of flux on here. That's what the shiny stuff is here. It's a little hard to see. We just need to make sure that nothing got shorted. Now we can't see the top side, that's the other problem. So we might need to kind of look at the schematics and just try to focus on this area. But I'm hoping before Brett put sockets in that they checked all the stuff on the top side. Okay, so this one here, we can see this trace got ripped right here. I'm just double checking it's not shorted to any of this other stuff. Nope, seems fine, but it is connected down here, so that's good. Okay, it looks like these two are connected to that rail. We need to double check the other board. Okay, so that one is connected to there, but that one's not. These are not supposed to be connected together, and they are here. Okay, so that could be our smoking gun right there. So again, I'm going from that via there to this pin, and they are shorted, and looks like Brett did a little repair there. But this is the same chip. There's that same via that is connected to there, but not to there. So that should not be connected together. And I'm not sure what that pin is connected to, if anything, but that could be, say, on a data line or something like that, causing our issue. All right, so I'll just put a little black mark right there to tell us that is a potential issue. I don't see any other repairs other than that, which we already confirmed is correct. I'm just going to quickly double check to make sure that none of these are shorted together. Obviously those two are, which shouldn't be. But before I remove that, I want to validate what this thing is doing first. And then we can take that off and see if that's our problem. It's hard to, there's so much flux on here, you really have to push hard to like poke through. Okay, yeah, none of the pins are shorted except for the two that I don't think should be. What I'd like to do next is I want to test all the chips that Brett sent along, and I'm going to use the C64 board to do that, just to speed up that process. And I'm going to solder in this ZIF socket first. A couple of the pins are actually soldered, I notice. But how ridiculous. And the amusing thing, the whole time I was blaming these like knockoff ZIF sockets as our problem when, I mean, really, amateur hour here, amateur hour. And there we have it. The socket is soldered into the board. What a novel concept. It should actually work now. There we go, booted right up very quickly. Awesome. And when it was having issues in that socket, what would you get is just a bunch of garbage characters typed in on the keyboard. The computer would always work fine, and I would just have to sort of press down on this or move the chip around. And like I said, I thought it was just a bad socket when it was not. So what we need in the other machine just to get it kind of booting is a CPU, a PLA, and a VIC-2 chip. The ROMs and SID shouldn't be needed, and in fact, because it's a regular long board, you shouldn't even need the two CIAs either. So for testing, I'm going to use this CPU, which I took out of another spare board. We will use the VIC-2 that was included from Brett, which is the R56A. And I'm not going to use the PLA that's normally in this machine. I'm going to use this, which is a Plankton. So that's one of the modern PLA replacements. The CPLD-based Plankton came out before Daniel Mantione's PAL-based PLA replacements. It uses two PAL chips. That's obviously the way to go these days because it's very inexpensive. You can just make them at home. But these types of replacements were all you could get back in the day. So we'll turn this on, and yep, there we go, it works. Yeah, and like color fringing on the text is coming from this R56A, but obviously it is working, so that's cool. I'm going to populate the board that Brett sent in with these chips that we know work. Keep in mind, sometimes the PLA is in this socket, depending on the revision. This one is the same as the ZIF board, and the PLA is up at the top here. And since this machine doesn't have any ROM chips, it's not going to do anything if we turn it on now, so I'm going to put in dead test cartridge so we can just replicate exactly what Brett saw. Here we go, 3, 2, 1. It's normal that we get a black screen for a little while. I'm going to switch to Des test in a second, which is more comprehensive and gives us visual feedback immediately. So we're just getting nothing. Oh, you know why? Because I have this in the wrong way, and dead test goes the other way. Oh, look at that, it just popped up. And the colors are different, but it's running code. It is running code. It's just obviously the characters are wrong. Okay, what I'm going to do next, I'm going to try DesTest Max. This is more comprehensive than the original Commodore Dead Test ROM 781220, which is in this. Because this actually, well, it does a lot more. And I've showed this off before, and I'll put a link in the description to this. Matt Desmond made this, and there's even a Switch version, which actually switches mode after it runs and tests the first 4K of RAM, which is all that Dead Test or DesTest can test. And with the Switch, it actually will test all the RAM, and it uses March testing to do the testing, which is a lot better and more comprehensive than the terrible RAM tests that are on both the Dead Test and the regular diagnostic. I'm just curious to see what exactly this will look like compared to the Dead Test. Interesting. Nothing. Okay, well, that could be a problem with my cartridge. I'm going to try DesTest Switch, which is the one I've recently used. Let's see if this one does anything. No, it should come up immediately. So it's funny that the DesTest cartridge is able to run and show stuff, but DesTest Max and DesTest Switch, it will show anything. So I can validate my test equipment. I have DesTest Max in my C64. Well, that's not working either. Let's just make sure this machine works after I put these chips back in. Okay, yeah, that works fine. Let's try DesTest Switch. Okay, this is how it's supposed to run. It runs through the test, and you notice when I turn the computer on, it comes up basically instantly. And on the other machine, when we put the DesTest Switch in, which we know is working, it does not come up. And I'm just going to double check. Nothing. Big fat zero. Okay, I'll be reaching out to Matt so we can try to troubleshoot exactly what's going on with his cartridge, because it should definitely work. Because let's put it in the Dead Test one more time just to validate that we're getting that same problem that Brett had. And then I'm going to go and clear out that little short that's happening on that one chip. And let's see. Yep, there it is. Looks exactly the same. What's curious here is it absolutely looks like it's running code, because I saw this earlier when I had this up. It started having a character running across the screen, which is what it does as it tests the RAM. There it goes. Yeah, it was like some kind of an addressing issue happening. Lots of weird faults here. Lots of weird faults. It is time to unplug this machine, and let's clear out that short that I seem to have identified on that one logic chip. Okay, the particular problem appears to be this small offcut. You know, I'm just wondering if this is like a mistake. Like, did this just get stuck here? It's definitely soldered on there. It's not coming off. Or is it? Okay, well, let me just get that off of there. Okay, that's all it took. Just a little touch of the soldering iron and it came off. That connection sure looks bad there, doesn't it? Okay, there we go. I think it was already connected. Just let me just reflow these just to make sure. All right, let's just double check things. So that is not connected any longer. And then that is connected. I'm touching that via under there. There we go. And again, this ripped trace, which this bodge wire is on, I just want to make sure it's not touching any of these things. It's not, but it's still connected. Okay, awesome. And let's see, I got to clean this flux up. It just makes it hard to see if everything looks okay. But yeah, I think this is all looking okay. All right, it's the moment of truth. I can't try to turn this on to basic because, of course, we're missing all the ROMs, but let's see what happens with the Dead Test. Let's see if we get a working system at this point. Oh my God, look at that, everyone. That is what it's supposed to do. Brett, I hope you're watching. All the desoldering you did not cause any additional damage to the board, at least not with the Dead Test. Let's pop in the DesTest Switch cartridge from Matt Desmond, because this can test all the RAM, as I mentioned. Dead Test mode, which is Ultimax mode, I think it's called, when the Dead Test runs, it can only read the first 4K of RAM on a 64. So DesTest Max, what it does is it first tests the first 4K in the same mode as Dead Test, the Ultimax mode, but then it actually reboots the computer and switches out of that mode into the normal mode. I'm pretty sure it does not need the ROMs, unlike the standard diagnostic cartridge. So let's see what happens. Okay, yes, it's running. Funny that des test does not work with that line shorted. So here it is testing that first 4K, and this is doing a March test. And boy, does that video quality look atrocious. But this VIC does not contribute to that. Plus, this is the worst RF modulator when it comes to the sharpness. I have a video that I mod the RF modulator. I show what you need to do on this just to increase the sharpness, and it makes a big difference. Let's see if this tests all 64K and it's working. Let's hope. Here we go. It's about to switch out into the full mode. There we go. It rebooted. Now we're running full, and you can see it says full RAM test on the top, and it's testing all 64K. I think this computer's fixed. It was literally a physical little short between those two pins. And I guess the question is, and only Brett can answer this, was that something that Brett added, or was that there, or was that a mistake? Meaning, like, while some other work was going on fixing like the bad traces, that little offcut got somehow connected up or something. So to really test if this computer is working or not, when you're going to need to install these ROM sockets while this RAM test is running, because we're going to have to put the ROMs back in. That way the regular diagnostic can work with the harness connected. And then we can see if these two 6526s that Brett installed are good. I might as well put this marginal SID into the computer as well, and I'll gauge how good that sounds once the machine is up and running actual code. This diagnostic test takes a long time to do all the testing because it's using March testing. So it's very, very thorough RAM testing. It's just slow, especially because the video is running. It's sharing bandwidth for the RAM with the video, and it's got to do some bank switching and stuff to be able to test all the memory. Well, des test switch has run through multiple passes because I've been sort of sorting out parts and stuff. Everything is working with the RAM. That's not to say there's not other faults with this machine, but the next phase I need to do is I need to get this machine fully back to stock configuration. So ROMs installed, all the ports hooked up, and I'm going to make a GAL PLA. I'm just about to solder up the little PCB here so I can put two GAL chips and replace the PLA with GALs as opposed to my Plankton. I only have one of these Planktons. I like to keep that around in my spare parts just as a, I don't know, thing of the days gone past, because we don't really need it anymore now that we have the GAL PLA. Okay, there it is. Motherboard is all back together. I have the marginal Chinese SID in here. I have the GAL PLA in there, and I think these are programmed. I found them in my stash, and it says L and R, so I think those are programmed for this. If it doesn't work, I'll need to check those. I installed these 3 ROM chips that Brett sent along. This is the 0.2 revision of the kernel, which is kind of buggy, but should be good enough just to get this thing up and running. Let's see if this thing boots to basic, because that is the ultimate test. Oh, look at that. It freaking works. Awesome. The next thing I want to do is I want to improve the sharpness on this machine. And the way you do that is we need to make a modification inside the RF modulator. And it only applies to this revision of the board, which has the MD6 VA3403 NTSC modulator. The later 64 long boards and short boards have much sharper video, so they don't really have this problem, but this particular revision just has that really soft video. And it's a really simple mod, but first we need to look at what the video looks like now before I mod it, and then after. Okay, so here we are in basic, and it's looking pretty soft, but I'm gonna boot up my Easy Flash cartridge just because I'm used to looking at the menu on this, and we can kind of get an idea what it looks like. Okay, it runs as well. Now you see around club games and game collection how the M is almost invisible. Yeah, we're gonna improve that. Now one thing I'm gonna need to do is I need to switch over to Luma Chroma, because that'll give us a better idea of like this improvement. So I'm gonna switch over to S-Video green blue. There it is. Or the color saturation is turned up a little high, but you can ignore that. Specifically, look at game collection. Around the M, see how sort of blurred together the M is? You can just barely see those risers. I'll link to the video where I've sort of discussed why this works and how this works, but the 2 things we need to cut are these 2 capacitors that I'm bending, the 2 that are around this small transistor. And all I'm gonna do is just from the top side, there we go, that one is cut, so I just cut one leg. Just bend it out of the way so it's no longer touching anything. And the same thing on the other one. And now if we turn on the machine, just ignore that. That's just a problem with my cable. Look at the M. Look how much sharper that is. It's an unbelievable improvement just cutting those 2 caps out of there. Look how crispy the video looks now. Absolutely amazing. And short of replacing your entire RF modulator, which of course will give you better video, this does a great thing. Now, we still have color smearing. Now, notice around A, B, C, D, E, F, G, see if there's a bit of yellow bleeding off to the side? To correct the color bleeding, what we need to do is we need to jump over this inductor. So there's this little white, I don't know, jumper link or whatever this is, but right next to it, this inductor there that's laying flat on the board, we need to jump it. So you need to solder a wire from that side to that side, and that should cure the color bleeding. So of course, with the system turned off, first thing I'm gonna do is I'm just gonna tin the top side on both sides, just to kind of help me get a wire onto there. And I'm gonna use a small little offcut. I'm gonna solder it onto one side first. And I know it's a little hard to see, but there it is. It's just sort of sticking up. I'm just going to tin the end. And it's a little hard to see, but I bent that down just so it's touching the other side now. And all I have to do is just sort of touch the soldering iron onto there. And yeah, that's connected on both sides. Perfect. And this is a good reason why you should keep offcuts like this off of components. Oh, yes. It didn't completely eliminate the smearing, but it is certainly better. Although, it's funny, there looks like there's a little bit of jail bars now. Yeah, that's interesting. And I mean, I'm talking about on the solid color. How interesting is that? I don't remember that being a problem before. You know, maybe you don't want to do that mod. My cables are sort of bad connections here because it adds those jail bars, and I don't really like those. So I think I'm gonna remove that. I'm just gonna lift it off one side. Let's see if that fixes the problem. Okay, I just lifted it. Oh, and the color is much more saturated now. I've done this mod before, and I always just jump over that component or just remove it and jump over it, and it looks really good. But in this case, it reduced the color output, and it also added those vertical lines, which are kind of unsightly. Oh, you know what though? I just realized that I think the reason for the vertical lines is the VIC chip. This VIC chip actually outputs those vertical lines in the color signal, and I think the RF modulator just sort of smooths that all over, which is why we're getting that bleed. But if this was an R8 VIC chip, then jumping over that component would eliminate the bleed, but also not introduce those vertical lines. So I'm going to call it and just say those two capacitors to cut is the thing to do, at least in this case. But your mileage may vary, and maybe you can jump over that inductor like I did, and it would look good. All right, well, at this point, we should be able to run the regular diagnostic cartridge, and that means I need to grab the test harness. Yep, this is running. So we need to test all the peripheral ports and stuff on here. So I have the test harness connected up so we can make sure that all of the I/O ports are functional on this machine. I feel like this machine was heavily brutalized, so this is probably a good test, just to make sure that we don't have bad traces. One of the pins on the joystick connector I re-soldered was the pad was missing, but I checked it on the top side and it definitely is connected, so I think it's gonna be fine. Right off the bat, we can see down at the bottom the two times. It says 000016 AM and PM, so that shows us that we have good communication with the 6526s, and they count up slowly as the test runs. So far, so good. I think we're almost there. Yes. I just had a thought, by the way, about the mod I did inside the RF modulator. Of course, it didn't make the video output or the composite video any sharper because it's a separate output amplifier versus the Luma. And the mod with cutting those two capacitors was only on the Luma line. So that's why there was no effect here. It's still pretty soft. But ultimately, if you're using a 64, hopefully you have it plugged into a monitor that has S-video so you can get like the highest quality image. All right, I'm really curious to hear what this marginal SID sounds like. Oh, yeah, that's a picture of me. I was playing around with an image converter, which I'll link to down below. And I made these images on the converter. And I was just playing around just to see, how it would look. And yeah, look at that. PS2 logo looks really quite good. Here's my channel logo, Adrian's Digital Basement. It's not perfect, but these were created with a web-based converter. This is not something that I did by hand or anything. And it looks like that. And then I have this one, Please Stand By, which is, again, fooling around. And I have Out to Lunch, which is that there. Yeah, I mean, it's pretty good, don't you think? It's not bad at all. Consider I didn't edit this by hand with any pixel editing. This was just strictly from PNG to this. Anyhow, what we're here to run is the 8-bit dance party. So let's hear how this SID sounds. Oh. Okay, no, the SID doesn't work. Yeah, okay, there's just barely some sound. It's super duper quiet. There you go, make some popping noises. So you buy an expensive SID from AliExpress, and this is what you get. Total crap. We could try a couple SIDs that I have on here. Let's try this one. Barely hear anything at all. I can just hear it playing ever so slightly, but it's just noise, and maybe it'll get loud occasionally. This one's a little bit more there. You can hear some of the filters are bad. That's what's happening. So these SIDs turn the filters off and on, and when they're turned on, some of them are bad. So that means that you're not getting any of the sound through. This one's working. Yeah, but it's not using the same filters these other ones are using. Oh, Legend Intro works pretty well too. But the SID's bad. So incidentally, I have a feeling if we ran the diagnostic cartridge and we listened to the sound test on the regular diagnostic, it probably sounds fine because this doesn't really use any of the filters. So this SID might test fine in here, but definitely you just heard it was not playing these other songs properly. So if you're going to buy a SID and you have access to it, or say the person selling it to you can record some footage, play some SIDs, like some of the ones that I just played on here, so you can actually hear the SID files that push the limits of the SID chip, just to make sure that it really does work properly, because this one, yeah, not working well. But I'm 99% sure when it gets to sound test here, it's going to work. Yeah, see? Bit noisy, but this sounds normal other than the noise. Oh, the sound channel, the noise channel is missing. Okay, so you'd still be able to tell from this that there was a problem. All right, so let's try an actual game. Yeah, the sound is working here as well. This is Hero by Activision, obviously, as you can tell by what's on the bottom. Pretty fun game, I like this. Bit more color fringing than you would get with a later version of the VIC-2 chip. It sounds a little weird, but it's definitely working okay. So that's what Brett said about this SID being marginal, in that it actually does kind of work. Okay, well, I got to level 7 and then, yeah, I bit it. Playing through the capture device really doesn't help the situation because it adds a lot of lag to the video. But this machine appears to be working just fine, other than the marginal SID. I just want to spend a moment to talk about what was actually wrong with this machine. What did I actually fix? Because I showed what I physically did, but we don't know what that actual short was causing. The short was on U13. This is one of the chips that was ripped out, and it was between pin 8 and pin 7. Well, we can see here that pin 8 is the ground pin, and pin 7, which was what it was shorted to, is one of the address lines, the output address lines. It goes to MA5 on all of the DRAM chips. So what these 74LS257s are, these are multiplexers. So these take the normal address lines that come from the CPU and it multiplexes them, because DRAM chips, as you can see, they only have 7 address lines, which really isn't enough for 64K of RAM. But that's because the RAM address lines are multiplexed by rows and columns. So we have, I don't know, just imagine like a grid inside the chip. Well, my mouse drawing skills are horrible. To access these various cells in the memory, you first address them with a row and a column, or one way or the other, I can't remember. And then these two signals, CAS and RAS, column address select and row address select, tell the RAM if you're addressing the rows or the columns. So that's what these multiplexers are doing. So when those lines were shorted, the addressing was messed up. And I mentioned that while I was making the video, because if you notice this table here, which is not supposed to look like this, has just sort of repeating. And then we had those little moving dots at the top, and they were kind of all moving in weird ways, like it was repeating over and over again. That is very indicative of an addressing error. When Brett was thinking that one of the data lines was stuck, specifically D2, that was a red herring. Essentially, software behaves very unpredictably when it's trying to use RAM to run code, and I assume that phase of dead test uses the DRAM because it's already tested it. And due to the addressing errors, whatever calculations it's doing or whatever letters it's displaying on screen get corrupted in a weird way that gave a false indication that data line 2 was stuck. But since this was actually an addressing error affecting specifically MA5 on the RAM, that means inside all of the DRAM, the memory that was stored in there or the data that was stored in there was going to be repeating in weird ways, like repeating over and over and over again. The RAM test for dead test is so bad that it can't actually detect that. It does such a simple RAM test that it's able to read and write from the RAM and it goes, oh, everything is fine. But when it goes to actually use the RAM, that's when everything gets corrupted because stuff gets overwritten as it writes to the memory. So when we removed the short that was between Y1 and ground, then all of a sudden the memory addressing was working properly and all this RAM was actually fine and there was really no problems. And the system just worked, as you saw. The repair didn't even require me to use an oscilloscope. All I needed was a multimeter with continuity mode to find that issue. And of course, I was comparing to another known good board. But generally, whenever you have things like this, where things are ripped out of the board unceremoniously with lots of damage, like Brett indicated from his letter had happened to this, it's really important to spend extra time and give extra attention to around those ICs to try to find a fault. I've learned that just from experience over the years, that if you ignore those types of issues, that can really bite you in the behind. And I'm still kind of amazed that Brett's desoldering work of all of these chips, everything else that wasn't damaged by the previous owner, didn't lead to any kind of faults at all on this machine. It totally works perfectly. So all that's really needed now for this machine to be a good, reliable C64 in the long term is replacement SID, and I just recommend like a SID kick. That's an open source project that replaces them. I actually have one on the ZIF64 and it works great. I have no complaints about it. It doesn't sound perfect, but you know what? Really, you won't be able to tell unless you're like a SID expert. And then of course, 3 printed metal plate and a new case. And then this is a great 64. So that's going to be for this video. If you liked it, thumbs up. If you didn't, you know exactly what to do. Huge thanks to my supporters and members. They make it possible to do this full time. You can become a member. There's links down below. Their names go up beside the screen. Subscribe if you haven't already. Thumbs up, comment, you know, all the usual YouTube junk. And of course, huge thanks to all my viewers who have sent stuff in and donated things to the channel, like Brett. Just makes it possible for content just like this. So that's going to be it. Stay healthy, stay safe, especially now, and I'll see you next time. Bye-bye.